Welcome students. In the module 1 and 2 we have seen about design mix in theoretical manner. In this module 3 of UNIT 3 mixed design, we will be seeing numerical problems on mixed design. So we will look into the problem in IS 102-62-2019 Annex A. So here the data are given like grade designation M40, type of cement Pozzolano Portland cement conforming to IS 1489, maximum nominal size of aggregate 20 mm, exposure condition severe, workability 75 mm, slump, concrete placing non-pumpable, and site control good, type of aggregate crushed angular aggregate, maximum cement content not including fly ash 450, admixture super plasticizer normal. So these are the basic conditions given, and the test data for materials is cement used PPC, specific gravity of cement 2.88, chemical admixture super plasticizer conforming to IS 9103, and specific gravity of coarse aggregate 2.74, fine aggregate 2.65. Here it is given as SSD. SSD means surface saturated dry condition, surface saturated condition, and chemical admixture specific gravity 1.145. Water absorption capacity of aggregate 0.51, moisture content of aggregate nil. So it is in dry state. Moisture content of aggregate, it is in dry state, and the sieve analysis is given. From that we have to look in which proportion it is lying, and the fine aggregate it lies in zone 2. So for this above data we have to provide a design mix so that all these properties specifications are satisfied. Okay. As we have already seen, there are 7 steps in mixed design, and there are more corrections also. We will look one by one. So first step is finding target mean strength. As we have seen, for calculating the target mean strength, the formulas are FCK plus 1.65S and FCK equal to FCK plus X. The values of S and X can be obtained from table 1 and 2. So if you go to table 1, you can get the value of X. Here we are designing for M20 grade concrete. Here we are designing for M20, it's given, sorry, M40 grade concrete. So here we are designing for M40 grade concrete. So we have to get values X and S for 40 grade concrete. So for M40 grade concrete, the value is 6.5 for X, and for standard deviation for M40 grade concrete is 5. So we will put these values. FCK it's 40, 1.65, standard deviation is 5, you are getting 48.25, and X value is 6.5, you are getting 46.5. Out of these two values, you have to adapt a higher value. So here the target mean strength is 48.25. So this is the first step. We have find the target mean strength. After that you have to find approximate air content. It is given in table 3. So if we go to table 3, based upon the nominal maximum size of aggregate, you can easily calculate air content. You can easily obtain air content of total volume. So here we are using 20 mm nominal size aggregate. So entrapped air is 1% of total volume of concrete. 1% of total volume of concrete. So we have find approximate air content also. The third step is finding water cement ratio. Here the cement grade is not given. So we are assuming the cement grade is OPC 43. So for 43 grade of cement and target mean strength of 48.25, we have to find water cement ratio. For that we are going to figure 1. So for 43 grade of cement it is curve 2, and target mean strength 48.25. Approximately if you look into it, you will get around 0.36. So 48.25 and curve 2, it's meeting somewhere around 0.35 range. So we have to approximately take it, we have no other option. So here they are taking it as 0.36. So we are getting 0.36. This we have to check with IS 456 2000 table 5. So they are given severe condition. For severe condition, the maximum free water cement ratio is 0.5. We have calculated, we have deduced from graph, it is 0.36. So 0.36 is less than 0.545. So this specification is satisfied. So we have found out water cement ratio also. Next we have to find selection of water content. Selection of water content. So table 1 and 2 we have looked X value and S. In table 3 we have found air content, volume of air content. In figure 1 we have found water cement ratio. If you go to table 4, you can find the water content. So here same, we are using nominal maximum size of aggregate 20 mm. For that, water content ratio is 186. But this is for 50 mm slump. This is for 50 mm slump. The slump we required is 75 mm. So we have to do slump correction also. So from the table we know for 50 mm slump it is 186 kg. But in this problem we are working out for 75 mm slump. So we have to calculate what is the water content for 75 mm slump. The correction is for every 25 mm slump increase or decrease, we have to adjust 3% of water content increase or decrease respectively. So 75 minus 50 it is 25 mm slump increasing. So we have to add water by 3%. So 186, when you add 3% of water you are getting 191.58 kgs. Also, since we are using super plasticizer, we can reduce the amount of water content. So if you are using super plasticizer, by 1% of weight of cement, you can reduce up to 23% of water content. So we are reducing 23% of water content. 191.58 multiplied by 0.77, it is giving approximately 148 kgs. So once we know the water content, we can easily calculate cement content using water cement ratio. We know water cement ratio is 0.36 and water content is 148 kg. From that, cement content is 411.11 kg per meter cube, which is approximately taken as 412 kg per meter cube. From table 5, we have to check whether the minimum cement content specification is matched or not. So if you go for IS 456 table, for severe condition, the minimum cement content required is 320. Here we are getting 412 kgs. So those specifications also match. Once these cement content calculations are done, you can go for proportion of volume of coarse aggregate and fine aggregate content. So we have to go for table 5. For nominal maximum size of aggregate 20 mm and given the gradation of aggregate is zone 2, you will be getting 0.62 volume of coarse aggregate in per unit volume of total aggregate 0.62. But this is for water cement ratio 0.5. We are using water cement ratio of 0.36. So we have to do water cement correction also. So how to do this water cement correction? 0.62 volume of coarse aggregate for 0.5 water cement. We have to find volume of coarse aggregate for 0.36 water content. The correction is 0.01 volume of coarse aggregate decrease for every 0.05 water content increase. If water content is increased, volume of coarse aggregate should be reduced. If water content is decreased, volume of coarse aggregate should be increased. So we have to find how much it is differed. So 0.5 is the constant and 0.36 we are using it. We have to find the difference, which is 0.14 decrease in water content. So 0.14 decrease in water content, we have to divide by 0.05 to look how many times it has decreased. It is 2.8 times water content decreased. For every water content decreased, we have to increase by 0.01. So 2.8 multiplied by 0.01, you are getting 0.028 volume of coarse aggregate increase. So initial coarse aggregate is 0.62. We are adding 0.028. So total volume of coarse aggregate in total volume of aggregate is 0.0648. So since coarse aggregate is 0.648, volume of fine aggregate is 1 minus 0.648, you are getting 0.352. Now we are doing volume calculations to find the weight of fine and coarse aggregates. We are taking as 1 meter cube. Volume of N shaft here 0.01 meter cube, 1% of total volume, 0.01 meter cube. Volume of cement, we are calculating mass of cement divided by specific gravity of cement into 1 divided by 1000. We know all these values. We are getting volume of cement as 0.143 meter cube. Similarly, we are calculating volume of water, 0.148 meter cube. Then volume of chemical admixture. Admixture, we are taking 1% of mass by cementitious material. So 1%, we know 412 kgs of, we are using 412 kgs of cement. 1% is 4.12 divided by specific gravity of admixture 1.145 into 1 divided by 1000. We are getting volume of chemical admixture as 0.036. So volume of all in aggregates. So total volume minus air volume minus volume of cement admixture and water. So volume of total aggregate is 0.695. So from this we can calculate mass of coarse aggregate. The formula is the value you are getting from G subdivision into volume of coarse aggregate into specific gravity of coarse aggregate multiplied by 1000. So you are getting 0.695. You have calculated in the G step. You know volume of coarse aggregate is 0.648. Specific gravity of coarse aggregate is 2.74 into 1000. So the total mass of coarse aggregate is 1234 kg. Similarly, you can calculate mass of fine aggregate as 648 kgs. So now we know the cement quantity is 412 kg per meter cube, water 148, fine aggregate 648, coarse aggregate 1234, chemical admixture 4.12 with water cement ratio 0.36. So these are the proportions. After that, what you have to do is you have to look whether the aggregate is in saturated surface dry condition. Here the moisture content of aggregate is, since it is nil and nil, it is in dry condition. Totally there are three conditions. First condition is dry condition. The second condition is the surface only gets saturated. Third one is wet condition. The calculations we have done till now is for saturated surface dry condition. So in this case here the aggregate is in dry condition. We have to do the water correction. We will see how to do this water correction. So first we have to find adjustment of water, fine aggregate and coarse aggregate. If the coarse and fine aggregate is in dry condition, from the data given we know the aggregate is in dry condition. So fine aggregate, mass of fine aggregate in SST condition 1 plus water absorption divided by 100. So mass of fine aggregate we have calculated above 648. Here the water absorption capacity is 1 by 100. So if you do this calculation, you will get the mass of fine aggregate is 642 kg per meter cube. Okay, 642. This difference, initially we at surface saturated condition we have calculated 648 kg. On doing the correction it comes as 642. The volume of mass of fine aggregates gets decreased. This difference you have to add it in the water. So similarly for coarse aggregate, mass of coarse aggregate in SST condition we have calculated it is 1234 and water absorption capacity of coarse aggregate is 0.5. Upon doing this calculation, so you are getting 1224. Here also, since it is in dry condition, you can take lighter concrete. So this difference 1234 minus 1228, this difference in weight you have to add it as water. So for coarse aggregate 1234 we calculate in an SST condition. Upon dry condition it is 1228. So 6 kg there is difference. Similarly for fine aggregate on SST condition it's 648. On dry condition it's 642. There is a difference of 6 kg. So while taking fine aggregate, it is sufficient to take 642 kgs of fine aggregate and coarse aggregate at 1228 kgs. So these two differences, 6 plus 6, 12, you have to add it in the water content. This water should be added to the mixture so that the aggregate surface gets saturated. So the water content, the amount of water to be added increases from 148 kgs to 160 kgs. Finally, the cement 412 kg per meter cube, water 160, fine aggregate 642, coarse aggregate 1228, chemical admixture 4.12 with free water cement ratio 0.3. Upon arriving this, you have to do the trial mix and check the concrete at various stages for the satisfaction of requirements. If the requirements are satisfied, this design mix can be forwarded for mass batching. Thank you.